Hi, this is Janak Reddy Dubaka. In this video, we are going to discuss one tricky problem from moving charges and magnetism. See, most of the student they know about only basic concept. For example, if any charge moving in a magnetic field, if it is moving parallel or anti-parallel to the field, the path is straight line. If it is moving perpendicular to the field, the path is circle. Therefore, for a circular path, radius r is equal to mv by bq, time period 2 pi m by bq. If the charge is entering into the field other than 0 degrees, 180 degrees and 90 degrees, and the path is helix, then radius of the helix, pitch of the helix, these are the basic thing. Now we are going to deal one important tricky problem based on this concept. See here. An electron is projected from the origin with velocity 3.2 I cap plus j cap meter per second. A uniform magnetic field of 2 k cap Tesla is present. The path followed by the electron is correctly shown. See here, velocity v bar is equal to 3.2 I cap plus j cap, and b bar is equal to 2 k cap. If the velocity has a component along b bar, if velocity has a component along b bar, path is helix. Next, if velocity has no component along b bar, path is circle. Path is circle. See here, velocity has a component along x direction and y direction, but magnetic field is along z direction. Means here velocity not having any component along b bar. Therefore, here the path is circle. Therefore, option 1 and 2 are eliminated. Now, option may be 3 or 4. Or, for example, if b bar dot b bar, here b bar dot also b bar dot b bar dot b bar also 0, means b bar and b bar are perpendicular. In that case also, path is circle. Now, from this option 3 and 4, we have to find out which one is correct. See here. For that one, the path can be decided by force vector and also velocity vector. See here, force F bar is equal to Q into V bar cross B bar. Here charge is electron, therefore minus E into V bar cross P bar. Therefore F bar is equal to minus E into what is V bar, 3.2 I cap plus J cap cross B bar is 2 K cap. Therefore F bar is equal to, here 3.2 into 2, that is 6.4, minus 6.4 E, then I cap cross K cap, that is equal to minus J cap, plus J cap cross K cap is I cap. If you multiply with the negative sign, therefore F bar is equal to 6.4 into E, therefore J cap minus I cap. Therefore here F bar having a component along positive y direction and negative x direction. Positive y direction and negative y direction. Here the circular path is in xy plane. Why? Because here magnetic field is along z direction. Therefore the path of that charge is perpendicular to the plane containing b bar, that is xy plane. Therefore both are is an xy plane. But which one is correct? Here force vector along its components are plus y and minus x. In circular motion, the center of the circle is the direction of centripetal force. Therefore, here the centripetal force is acting towards the center. This is the force F. Here the centripetal force is toward the center F. Therefore, this F is having component along positive y direction and negative x direction. Here the force component, one is positive x direction minus y direction. But our problem, according to our problem, the force component having plus y and minus x. Therefore, option 3, in option 3, this force vector having plus y and minus x. Therefore, answer is third one. See how tricky is the problem. We know only the basic thing. This is the concept. It's a very, very important one.